From the dawn of time, humanity gazed upon the sky with a mix of fear and wonder. The raw, untamed power of lightning, a fleeting spectacle of nature's might, was a mystery, a divine spectacle that hinted at a force far beyond our grasp. For millennia, it remained just that. A terrifying, beautiful spark in the darkness, a primal force of nature that we could only observe from a distance. Our first fumbling attempts to understand this force began not in the storm, but with simple, curious observations. Ancient civilizations discovered that rubbing amber against fur created a strange attraction, a crackling magic they called electron. This static electricity, a parlor trick for centuries, was the first clue. A faint whisper of the immense power waiting to be understood, slowly guiding curious minds through the 17th century. The turning point came in 1752, with a flash of genius as daring as the lightning it sought to understand. Benjamin Franklin, armed with a kite and a key, flew his experiment into the heart of a thunderstorm. He proved that the spark from the sky was the same as the spark from the amber, capturing a piece of the storm in a jar and demonstrating that this celestial fire could be brought down to earth. This revelation ignited a scientific revolution. In the late 18th century, innovators like Alessandro Volta sought to create a steady, controllable flow of this power. By stacking discs of metal, he created the first battery, the Voltaic Pile, transforming static sparks into a continuous current. For the first time, humanity could generate a sustained electrical charge on command, building the first simple circuits with a flowing current. The next challenge was to measure and define this invisible force. In the early 19th century, scientific pioneers like André-Marie Ampère and Georg Ohm meticulously experimented, establishing the fundamental laws of electricity. They gave us the concepts of current, voltage, and resistance, creating the language and mathematics needed to truly engineer with this power. The true leap towards our modern world happened in the mid-19th century. Michael Faraday's groundbreaking discovery of electromagnetic induction revealed that moving a magnet near a wire could generate a current. This principle led to the birth of the electric generator, a revolutionary device that could convert mechanical motion into a virtually limitless supply of electrical energy. By the late 19th century, this newfound power began to push back the night. The first electric arc lamps flickered to life, casting a brilliant, steady glow over city streets. These novel streetlights transformed urban life, making cities safer and extending the hours of work and leisure, forever changing our relationship with the darkness. Soon, this light moved from the streets into our homes. In the early 20th century, the era of domestic electrification began. Families gathered to witness the marvel of the first incandescent bulbs, and early electric appliances started to ease the burdens of daily chores, heralding a new age of comfort and convenience that was previously unimaginable. To deliver this power, a new kind of infrastructure was born. Vast grids of power lines and transmission towers began to stretch across the landscape, an intricate, invisible network connecting power plants to every home and business. This monumental engineering feat united communities and nations, laying the groundwork for a truly interconnected world. Today, we live in the electric age. From the smartphones in our pockets to the sprawling data centers that power our digital lives, from electric vehicles to the renewable energy sources that promise a sustainable future, electricity is the invisible lifeblood of modern civilization. What began as a spark of wonder in the eyes of our ancestors has been harnessed to build the world of tomorrow.